In today's note, we are going to look at the most complex type of equation that we're going to be solving in this course, and that is equations with fractions. Now, I know how much everyone loves fractions, but we're going to look at how do we get rid of fractions so that we can make our equation easier to solve. So, to solve, basically, to remove the fractions by multiplying both sides of the equation by a number and then solve as we did before. And the reason we're doing that is because if I look at the most simplest example here, x over 5 equals negative 2, remember, fraction or this line can represent dividing. And how do we cancel out dividing? Well, we do the opposite operation, which is multiplying. So if I look at my first example, x divided by 5 equals negative 2, or x over 5, I want to multiply this side by 5. Actually, let me use the same color I've been using. So I want to multiply the one side by 5. I'm going to do the same thing to the other side to keep things balanced. The one side, they cancel out or become 1. So x equals negative 10, which is my final answer. So in our most simplest way, we're getting rid of that fraction or that divided by 5 by multiplying by a number, in this case 5. If I look at b, b is a little bit different, but what I can do is I can change this into something that I'm more familiar with. So you could think of it as 1 over 5 times this bracket, or basically, remember, any whole number is a fraction over 1. And from our understanding of fractions, when I multiply, I just multiply straight across. So I basically get x minus 3 all divided by 5, right? 1 times the top, or the bracket, 5 times the 1 is 5, equals 2. Now this is something similar to what I just looked at, except I have more on the numerator. Either way, though, it's still fine, because if I multiply the one whole side by 5, and I multiply the other side by 5 to balance it out, I can see that one side cancels out. I'm left with x minus 3 equals 10. Again, the reason I multiplied by 5 was because I had been dividing by 5, right? Or that fraction was over 5. Now, this is a one-step equation that I'm used to. So to get rid of minus 3, I'm going to add 3, do it to both sides. X equals 13 is my final answer. Looking at example C, this is something similar to what I've done, but again, now it's a little bit more complex because I don't have just a 1 on top of my fraction that's in front. However, I'm going to treat it the same way I've been doing it. I'm going to basically combine these two, right? If I multiply them together, I get 3 times x plus 1 over 4. So basically just multiplying my fractions here equals negative 6. And now I can see my one fraction, or my one side, is all divided by 4. So in order to cancel out dividing by 4, I need to multiply the one side by 4 and multiply the other side by 4. One side will cancel out. I'm left with 3 times x plus 1 equals negative 24. And now I've gotten rid of my fraction. I do have a distributive property to take care of, which I'm comfortable, or I should be comfortable doing from our last notes. So 3x plus 3, oops, forgot the x. 3x plus 3 equals negative 24. Try to ignore that example D. I know it looks scary, but we'll get to it in a second. I'm going to minus 3 from one side, minus 3 from the other. So I get 3x equals negative 27. Divide, oops, moved on me. Divide both sides by 3. And again, missed canceling some things out. But then we get x equals negative 9 as our final answer. So even though our fraction was a little bit different, we still went through the same steps, multiplied by a number to help us get rid of that fraction, and then carried on from there. Now example D, we have two different ways we can look at this. So I'm going to show you two ways and then of how to get to the same idea, and then we'll continue on and solve it just in one way. So here I have two fractions on both sides of the equation, or equal sign. I'm used to, or should be familiar with, how to combine them based on my understanding of multiplying fractions. So the one side should be 2x plus 1 divided by 3 equals 2x minus 3 divided by 5. Here, I'm going to start on the left side. I have a fraction, or I'm dividing by 3. So how do I cancel out dividing by 3? Well, I have to multiply everything on the one side by 3 and everything on the other side by 3, right, to keep things balanced. They'll cancel out on one side, so I'm left with 2x plus 1 equals 3 times 2x minus 3, all divided by 5. Right, so that multiplied by 3 is still up there at the top. I still have this fraction on the right side, so how do I get rid of the divide by 5? Well, I'm going to multiply the one side by 5, and I'm going to do the same thing to the other side. I'm putting brackets around the 2x plus 1 because everything on the left side has to get multiplied by 5 in order for it to be balanced. One side cancels out, and I'm left with 5 times 2x plus 1 equals 3 times 2x minus 3. And this is something we can solve because we've done something similar like this where we've expanded and solved. So that's one way you can look at solving this. The other way you can look at solving this, and again, I'm going to continue with just how we simplified it. So 2x plus 1 all divided by 3 equals 2x minus 3 all divided by 5. So another way we could simplify this, because we have to multiply both sides by a number to get rid of these fractions, we can pick a number that 3 and 5 divide nicely into. Right? Again, remember that line in the fraction represents divide, so we're going to have to divide by 3 and 5. So if we can find a nice number that both 3 and 5 divide into, or a number that they both nicely divide into, then I can multiply both sides by that single number to help me cancel them out at the same time. And if we think about it, what number does 3 and 5 both go into? And the answer is 15. So if I multiply both sides by 15, let me just move this one over just to give myself a little bit of space. Oops. So I'm going to multiply both sides by 15. Again, I'm putting brackets around the top because the entire thing on top is multiplied, not just the first term. Now I can help cancel out because 15 divided by 3 is 5. So that helps me cancel out the multiplying and the fraction. So 5 is left times 2x plus 1. And then 15 divided by 5 is 3. And then 2x minus 3. That divided by 5 is gone. And we end up with the same answer, right? So these two are the same. We're at the same step. One we multiplied by a single common number that 3 and 5 divided into. The other one we did our standard way by just multiplying both sides by the denominator and working our way through there. So again, either way you choose to do it, you still get the same answer in the end, or at least to the same step in the end. So then now what we can do, let me just use a different color. Now we can basically just work from this one step. So if I want, let me just rewrite 5 to 2x plus 1 equals 3 times 2x minus 3. So again, we just basically go right to here. So either way either way you get to this step is fine. Multiplying the 5 into the first bracket, multiplying the 3 into the second one. So 5 times 2x is 10x, plus 5 equals 6x minus 9. I have x's on both sides of the equal sign, so I do need to get them to one side. So I'm going to minus the one side by 6x, minus the other side by 6x to balance it out. Cancels out, so 4x plus 5 equals negative 9. I am then going to help or work on canceling out the subtraction. And in order to do that, I'm going to minus 5 on both sides to get rid of that plus 5, minus 5. So I'm left with 4x equals negative 14. And the last step, I'm going to divide by 4, divide by 4. Ooh, I'm forgetting to cancel things out here. And I'm left with x equals negative 14 over 4, which I can simplify to negative 7 over 2. So just a little bit longer, and my last answer is in a fraction. So looking at E, we have kind of the same idea, except now we have fractions on both sides. So how do we get rid of the fractions again? We have to find a common number that I can multiply everything by to help me get rid of these fractions. So what's a common number that goes into both, or that 3 and 2 both divide nicely into? And if you think about it, you can think about it, and if you're having trouble finding this nice number, the easiest thing to do is just take your two denominators, or 3 and 2, and just multiply them together. And we get 6. So we know that 3 and 2 are going to divide nicely into 6. The same thing with the last example, the 5 and the 3. 5 times 3 is 15. That was our nice number that we picked. So I know my nice number is 6, so I'm going to multiply everything, or every single term here, by 6 to help me get rid of those fractions. The reason I'm multiplying everything by 6 is to balance everything out. So when I multiply by 6 in the first bracket, or the first term, the 6 and the 3 cancel out to leave me with 2, or 6 divided by 3 is 2. So it's 2 times everything up top, so the 4x plus 5, minus, and then the 6 times 2, or 6 divided by 2, sorry, is, I'm left with 3. So 3 times 3x is there. And then 6 times negative x is just negative 6x. There's nothing to cancel out there. Now I have some brackets to take care of. So the 2, I'm going to distribute the property into the first set of brackets. So 2 times 4x is 8x plus 10. I'm going to take care of this multiplying as well, because it is separate from it is a separate term, or it's separated by that minus sign. So 3 times 3x is 9, but I'm subtracting it, so minus 9x equals negative 6x. Now I have multiple variable terms, or multiple like terms, that I need to combine, at least on the one side. Right? I'll worry about combining them on the other side later. So 8x plus 9 plus negative 9x is going to be negative 1x. The plus 10 remains. There's nothing I can combine it with. Equals negative 6x on the other side. Now I can work at getting my x's together on the same side. So I'm going to get rid of this minus 1x on this side by adding 1x. I'm going to add 1x to the other side. One side will cancel out. I'm left with 10 equals negative 5x. And now I'm going to solve by dividing both sides by -5. One side will cancel out. X will equal -2, which is my final answer. So again, a little bit more complicated, but when I'm dealing with the with multiple fractions with different denominators, again, the easiest thing to do is to just, let me just put brackets up here, is to just find a common number that both the denominators go into, multiply every term by that number to help you cancel out those fractions. So if you're going through solving equations and you find that your answers are coming up wrong, so some things you want to check first. Did I multiply everything by the number? So as we're going through this, did I multiply everything by the number, right? So when I'm distributing the property, did I multiply everything? When I'm trying to get rid of my fraction, like I see up at the top, did I multiply everything by the number, right? Whether it's brackets around the term, whether it's whether it's all the separated terms, whether it's everything on both sides, did you multiply everything by the number? Did you skip steps, right? So did you try to take a shortcut and do multiple steps at once, right? If you're finding you're getting the wrong answer, maybe you should go back and write out all the steps, so then hopefully you kind of catch your mistake or you don't miss something. And thirdly, one of probably the most common mistakes, and it probably frustrates a lot of people, just check the signs. Check the positive and the negative, right? Make sure your signs are correct. Make sure you're looking at the sign in front of the term to help identify what sign it is, because that tends to be one of the most common mistakes. And then if you can't find your mistake, or you're not sure where your mistake is after going through those 3 steps, ask for some help, right? It doesn't hurt to ask for help, because again, that's where you'll learn where your mistake is and then be able to hopefully correct it the next time you go through. But again, the main thing from this lesson is just being able to get rid of your fractions by multiplying by a number. And then once we do that, we take ourselves into either distributive property, solving equations with brackets, multi-step equations, 2-step equations, or 1-step equations. So really you're starting out with complex situation, and you're breaking it down step by step by step into something simple and manageable.